Yeah, good afternoon. I'm Anil Kumar, and this is our internship project, washing machine, and application of an embedded system. Yeah, things we learned from this internship is introduction to C, conditional loops and operators, arrays and pointers, functions and strings, storage classes, embedded system and microcontroller, microwave oven project, MPLab, XEB, PICSIMLab, introduction to various peripherals of PIC16F877A, interfacing various peripherals of PIC16F77A, and various quizzes. And the next is table of content. Yeah, introduction to embedded system, components of embedded system, embedded programming, about the project, pro- project implementation. Yeah. Introduction to embedded system. Yeah, an embedded system is a system which consists of microcontrollers, microprocessor, and a programmer. These all together connect with the hardware system to do a specific task within a larger device and to control functions like sensing, processing, and output. Yeah, it consists of microcontrollers and microprocessors. Yeah, these microcontroller and microprocessor are connected with the sensors and actuators. Yeah, these sensors are taking input from the environment, and these actuators are give the output, which comes from the processor. Yeah, some examples of embedded system is washing machines, traffic lights, smartphones, and etc. Uh, yeah, these are some components of embedded system. Input ports, output ports, memory, other devices, and system core. Input ports means these ports are connected with microcontroller or microprocessor and sensors. Yeah, uh, which connected to the microprocessor to take the input from the sensors, and this passes to the microprocessor, and the output ports which connected between the microcontroller and actuators, which pass the processor data which from the microprocessor, and the memory. A memory, it is built in microprocessor which stores uh, the data or processor data from the sensors and actuators. Yeah, system core. System core of an embedded system includes the microprocessor and microcontrollers, FPGA, etc. And 8085, 8086 are a few examples of microprocessor. ARM, DSP, digital signal processor, 8051, PIC, peripheral interfacing controller, and are a few examples of microprocessors. Embedded programming. Yeah, this is the crucial thing in a embedded system. The system, embedded programming refers to writing a software that runs on an embedded system, which are specialized computing devices designed to perform a specific task. Yeah, we have a task, and that will be done by what we give to the embedded system through the code. It involves low-level programming to control hardware components like microcontrollers, sensors, and actuators. These are the most yeah, these are the most popular languages for embedded systems like C programming, assembly, C++, Python, Java, and Rust. Yeah. Yeah, difference between C and embedded C is C is a general purpose language used for developing softwares, like Windows, Linux, or Mac. While come from the embedded C is specially designed for controlling hardware in embedded systems. C runs on computer with operating system like Windows, Linux, or Mac. C program have more memory and the processing power available. From Comes from the embedded C. Embedded C runs directly on hardware without an operating system. Yeah, we don't need of any operating system like Windows, Linux, or Mac. Yeah, this embedded C will directly connect it to the hardware devices, and this embedded C must be optimized for small memory and low power usages only, as embedded devices have a limited resources. Yeah, introduction to embedded C. Yeah, embedded C is a programming language specially used to develop a software for embedded system. Yeah, we already discussed about embedded C. It will be connected to the hardware system directly in the embedded system, uh, which uh, which are small computing devices designed to perform dedicated functions. It is an extension of a C programming language, but with additional features that allows direct interaction with the hardware components like microcontrollers, sensors, and actuators. Yeah. There are key features in embedded C is uses standard C syntax similar to C, including loops, functions, and conditions. Yeah, direct hardware access uses registers ports to control the hardware components. No standard library functions, efficient memory management, real-time processing. Yeah. From this topic onwards, my friend Kausik will explain. Thank you.
Today we are going to discuss about the embedded internship that I am doing with my colleagues Mahesh and Anil Kumar. Today I am going to explain about the data types and the variables. Embedded C uses C data types. The C is a kind of language which is like a interface between the user and the microcontroller that we are using. Generally we use C language for prototyping and writing the code for embedded systems. Since it has a close similar applications with the hardware. Embedded systems are with limited memory and the limited processing power. It also includes hardware-specific data types that interact directly with microcontroller registers and the memory locations. For every microcontroller there is a datasheet and there contains the port address. For the memory locations we can manipulate the bit data in them using C language. Data types are basic data types and the derived data types. Basic data types and derived data types we talk about them later, and the variables like global variables and local variables. Basic data types. The basic data types are the primitive data types. Dennis Ritchie was the founder of the C language. While doing them, he discovered and invented about the data types such as int, char, float, and a double. The integer generally is 32-bit. 32 takes 32-bit memory in the processor, and the char takes 8 bits, and the float takes the 32 bits, and the double takes the 64 bits. The arrays are the data types. Data types are the data types that are derived from the basic data types that are arrays, pointers, structures, and the unions. Using the data types, we can manipulate the port address and the ports and write the data of we required into the ports. Those data types includes the arrays, pointers, structures, and the unions. PIC microcontroller. PIC stands for Peripheral Interface Controller Microcontroller. These are 8-bit general purpose microcontrollers. For the microwave oven project simulation, we are using the PIC microcontroller. We have various PIC microcontrollers. Among them, we are currently using the PIC 16F8777A, which is a 8-bit general purpose microcontroller. It contains a RISC architecture, reduced instruction sets. Since the instruction sets becomes very less, it is easy for the microcontroller to run the program and do the processing things. The flash memory and the features of the PIC microcontroller are there in this. Flash memory is generally used to store the data into the RAM or ROM. The architecture of PIC Simulac contains the PIC microcontroller. The PIC microcontroller consists of GPIO, general purpose input-output ports, and the registers. We can manipulate them using pointers, address in the memory. The I2C is a communication protocol, and using that we can store the data in using RTCS through the address real-time clocks and the EEPROM. LM35 is a temperature sensor, real monolithic 35, which contains the BJTs and others. The temperature range of this sensor is minus 55 degrees Celsius to 150 degrees Celsius. It is supportable for the communication of RS-232, that is serial communication, and the LED's patterns can be done using the G5 ports of PIC 16F877A. Buzzer is given as an input to the our microcontroller. Digital keyboard also can be used, which is used in this project of washing machine. SSDs are the solid state device drivers, which is used to store the data in the modern era. Matrix keypad and digital keypad. Keypad is generally used as an input to store the data to give input to the big microcontroller. Peripherals that we used in the projects of the microcontroller. CLCD, the character LCD. LCD is liquid crystal display. It is a type of display screen used in numerous applications. It is very low power consumption as compared to LED. LCDs are very thin and as of several types. Two polarizer planes with a liquid crystal solution is sandwiched between them. Light is projected through the layers using the LED backlight and polarized as it presses, thereby producing the visual image. When electric current is applied to liquid crystal molecules, they untwist, resulting in a change in the angle of light. The polarized layers are responsible for either blocking light or allowing them to pass through them. A reflecting mirror is arranged at the back of the unit. It contains of 16 pins, and the 16 characters can be arranged in a row, and the two rows are present in the LCD. Generally, we use the JHD162A LCD display. It contains of 16 pins named as VSS or ground, VCC, and VRE for LCD contrast, RS for instruction registers or data register selection, read and write selection, and enable signal, and DB0 to DB7 input lines, and LED supply plus to 5 volts, and LED minus supply to the ground as default. It can be used to display the 4-bit also, like nibbles. It is used to show the text, numbers, and the symbols. Receives data from the microcontroller as an input and process the data and displays them. The second peripheral that we are using in this project is the matrix keyboard. Matrix keyboard or matrix keypad is a keypad with multiple buttons used in rows and columns. The rows and columns contains the generally in this project we used 4 into 4 matrix keypad. In that we have 16 buttons. In that we have 4 rows and 4 columns. The rows are connected as an output to the microcontroller, and the columns are connected as input to the microcontroller. It is used to reduce the number of required pins. It reduces. We have 16 buttons. Instead of using 16 pins, we can reduce them using 4 and 4, 8 pins. It is commonly used in embedded systems for calculation process, ATMs, security systems, and industrial controllers. About this project. In this project, we are simulating the washing machine, which is a recognized application of embedded systems using PixSimLab. What is a washing machine? Washing machine is generally a household purpose which we use for cleaning washing clothes and with the help of water and detergent. It functions through multiple modes of operations such as wash, rinse, and spin according to the types of cloths which we are using for washing, and also of special applications and settings like a quick wash, heavy wash, duplicate, and drying depending on the cloth type and model. It simplifies the manual task of laundry, which is a general process that we use in the homes, by automating the process through pre-programmed control logic. With this integration of embedded systems, modern washing machine ensures improved efficiency, timing control, and user convenience. We can, as per our convenience, we can use the washing machine whenever we are free and when we can do our works. A washing machine is a everyday life, household life example that uses embedded systems to automate the process of cleaning. Unlike traditional mechanism like mechanical machines, modern washing machines are equipped with intelligent microcontrollers and electronic control systems that manage all functions and precision with efficiency. Now my friend Mahesh will continue about this project.
Hello everyone, I am Emertxe, and let me continue the presentation about the washing machine which we made which we made during our internship period at Emertxe. So let me explain the code using MPLab. So as you can see, these are all the header files we used for the washing machine, and the source files, which are C files, are also used. So there are various header files including CLCD for the LCD display, digital keyboard for operating the keypad in PiximLab, timers for the timing purpose, and the main header file to coordinate all this, and source files CLCD, digital keypad, and also you can see the main C file which is used to control to coordinate between everything, and it is the main code. So let us explore the code. As you can see there, this is the timer control code, and this is CLCD used for displaying LCD. Now coming to the main C file. As you can see, we started with including main header file. Next, we explore the various functions of washing machine program, which are daily, heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, resin and dry. And also, after selecting any of the options, we can go into the next step where we select water level: auto, low, medium, high, max. So you can select one of these options as your water level, and after that we let us explore. As you can see, the print functions, CLCD print functions are used. Press key 5 to power on the washing machine, which is displayed in the LCD in the PiximLab, and it indicates when button SW5, which means RW4 in PiximLab, is pressed, the washing machine is turned on. And SW5, as you can see, we also assigned pause and start. As you can see, we also assigned start and stop options to SW5 and SW6 switches, which are used for starting the function and stopping the function. And all this code used for the displaying of the function which happening in the washing machine. So when SW5 is turned on and it is start, the fan starts rotating in PiximLab, which indicates the operating of washing machine. While it is operated, a timer for the operation is displayed on the CLCD. As you can see, these are all the switch cases to select various functions and water levels in the washing machine. And this door status check function. So we assigned RB0 with the door open option. So when we press this button, the door of washing machine is opened and buzzer is on, and also the fan, which indicates the operating of washing machine, is turned off, and function also turns off, and timer passes. And LCD displays door open and please close. So the operation only resumes after we close the door. So when we close the door, you can see the fan is on and the timer is also turned on. As you can see, the buzzer is on and fan off and timer is off during the door is open, and it is back to normal when we close the door. As you can see, there are various options: spin and resin. So this is all the code I can explain. So now let us do the execution. We are using Pixim Lab for the execution. So now let us load the hex file required for this washing machine. So as you can see, we opened the production, and so as you can see, I set the clock frequency to 20 mAh, which is suitable for this program. And now press key 5 to turn on the washing machine. As you can see, I am pressing RB4, which is SW5, to turn on the washing machine. So let me start it. As you can see, it is turned on. Now as you can see, we can explore the various washing programs, which follows by as daily. You can toggle the options by using RB3: daily, heavy, delicates, whites, stain wash, eco cloths, woolens, bed sheets, rinse and dry only, and wash only. So let us do the wash only now. So to start the wash only option, we need to press and hold RB4, which is SW5 button. Sorry, RB3. So when we hold it, it goes to the next option where we choose our water level. So as you can see, we can toggle between the water level options, which are auto, low, medium, high, max. So let me select the water level by holding the same button again. As you can see, I set the water level to high. Now I press SW5 to start the operation, which means RB4. So let us start the operation. So the timer is set to 26 seconds. The function wash is started. So as you can see, the fan is rotating to indicate the operation is begin. The function is presently wash. Now let us open the door. As you can see, when I press the RBO button, the door is opened and it indicates please close. So all the operation we are doing is paused when we open the door. Now let me close the door. As long as I am holding the button, it won't be closed. So as you can see, now I close the door and the operation continues as it is. As you can see, the program is completed. When the program is done, it is again back into the first menu where we choose our function, whether it is wash only or aqua dry or anything else. So again we can choose the option we need and continue our our usage. So I thank Emertxe for giving this opportunity and all the training they have provided us during this internship to improve ourselves during this summer period. Thank you.